Now that you know a little bit more about mappings, I want to touch on a different kind of data structure, and that is structs. And there might be a confusion how to use them and where to use them. And I especially want to compare them in this lecture against contract instances or objects of contracts instead of just using structs, and touch a little bit more about when to use what and the gas usage and so on. So I want to get started with a sample smart contract that uses a subcontract as an object to store some values. And let me give you an example. Let's get started with, I don't know, an example structs solidity file. And then let's bring over the SPDX license identifier and the pragma line as usual and call this. So I'm going to use two contracts here now, and I know I'm going to go ahead a little bit because we haven't really talked about contract interactions and so on in depth, but just follow along. I think it will be pretty clear what is going on here. So I will have a contract that acts like a wallet, and every time you receive something, I'm going to, well, in this case, I'm just going to store like a subcontract that holds the values for the actual payment received, how you would do it normally in an object-oriented programming language with classes and like with classes to have a logical group of variables. So I have a contract wallet, for example, and that has a function, I don't know, pay contract that is public payable, just an example. And over here, I want to store the from whom is it, like who sent this and how much. So I could do here address sender and uint value sent, and then I could do over here sender is message sender and value sent is message value. Now, before even going into how we can map this and so on, is there a way to logically group this together into something like a payment received? And yes, there is. There's two ways to do that. One is with structs, and the other one is with subcontracts, or, well, contracts that hold this logical group of variables. Let me give you an example with the contracts first, and then simplify it with the structs. So we have a second contract that we call maybe payment received, and over here we actually say address, I don't know, public from and a uint public amount, and then we maybe have a constructor that stores these variables, address from uint amount, and then the from is the from, and the amount is the amount. And then we somehow need to reference that over here. So we could do over here payment received, public payment, and over here we just say payment is new payment received, and then the message sender and the message value. So if you're going to compile this, it compiles just fine. And if you're going to deploy it, be careful over here that you deploy the wallet this time. If you deploy the wallet, nope, there's something in there which shouldn't be in there. So if we deploy the wallet and we say pay the contract with one expensive way, then it will create a new smart contract payment received for us, and it will store the values of the message sender and the message value into this smart contract. So we are going to call this function, and this one creates a new payment received smart contract, and it will input in the constructor the from and the value. So if we are getting the payment over here, the getter function, the question is what is going to be returned. And over here, it is going to be returned the address. And with this address, we can then instruct Remix or whatever kind of software we are using to actually fetch at this address from the payment received contract the actual variables. Let me show you how that works. So now we click on payment and we see a new smart contract was created at this address. So we can copy this address, paste it over here, and say our payment received smart contract, it's a different one now, is living on this address. So if we say add address, then we get a new interface that interacts with this smart contract at this address. And then we can say the amount. Yes, we send one way, and we send it from this message sender over here. So it's going to be the same addresses over here. So AB 8 and so on. So the question is, what are we gonna, can we simplify that? Or is there a benefit in doing it this way versus a simplified way? Now, before I'm answering this question, let me show you with a different smart contract how this can be simplified with structs. So I'm going to create directly underneath here a new contract, and I call this simply wallet2. And I'm having the same function pay contract, public payable. But in this case, I do not want to create a subcontract. I will create a struct over here. And the struct starts with the keyword struct, and it's a logical grouping of variables. And the logical grouping is inside curly brackets, but the struct also gets a name. So why don't we just call this payment received struct? So we don't have a naming confusion over here. And then we have an address from, and you finish it with semicolons. So it's not a comma, it's a semicolon, and a uint amount. And this one becomes a new data type. So now we can give a variable the data type payment received struct. So payment received struct, public payment. So the variable payment is now of the type payment received struct. And the question is, how can you access these variables inside the struct now? Now there's two ways. The easier one is payment received struct. Oh. You see, I don't have a new keyword here. So I'm just writing payment received struct, and then very much like with the constructor in the smart contract, message sender, message value. So it's in order of the variables that are defined in the struct. Or, well, let's give this a try before we're continuing. Over here, wallet2, deploy. And what happens if we are calling this public variable now? Let's send one way over here, pay contract. And then over here, we're getting the variables directly returned from our getter function. So we don't get an address because we didn't create a new smart contract. It is going to be directly the variables that are defined in the struct. Very convenient. Now, how do you access these values? I could also do payment.from is message sender, and payment.amount is message value. It is exactly the same thing as above, just, well, more clearly defined. It's up to your flavor what you're going to use in your smart contracts. I think sometimes this is more readable, but that's my personal opinion and shouldn't influence what you're doing. So the question is, when do you use what here? So what is better, a solidity struct or a child smart contract? And I have to say, most of the time, it is better to save gas with structs. And gas costs are pretty high. And if we are comparing the gas costs over here, let me make this a little bit bigger. Where do we have that? Wallet.pay contract needs around 221,000 gas. So if you multiply that with, let's say, 100 GUI, and say the network is congested and you have to pay 100 GUI times 221,000 gas, it can become fairly expensive if ETH hits a certain price. Now, on the other hand, with our Wallet 2 Pay contract, it only needs 75,000 gas. That's quite a gas usage reduction here. The other reason why you should use Structs is because to save complexity. Now with a child smart contract, if you want to update a variable over here, you kind of need to write setter functions, and then you need to take care of access lists, access rights, who is allowed to override what, and it can become fairly complex rather quickly. And then it's also a dry, do not repeat yourself, and KISS, keep it simple, stupid principle. You know, contracts are code, and every time you deploy code, it's possible to introduce bugs and so on. So the simpler you can keep it, the better it is, the lower the attack vector probably is going to be with Structs. Now, there's also good reasons to use child smart contracts, and that is since whatever information you want to put in the smart contract is then living there, you can have arbitrary complexity in there. So you can have you can fill in a smart contract with certain variables, and then do whatever you want with that smart contract. You can split up the code into subcontracts, but be aware that of the additional gas costs, so you're not running out of the block gas limit. Now, obviously, all of this makes little sense to just store one variable. And in the next lecture, I want to have a look at how we can combine structs with mappings.